In this section, we're going to talk about generating the inverse of a square matrix. Now, this is a rather involved little process, but it has its basis in the set of real numbers. And when we talked about real numbers, we talked about inverses and a related topic, identities. And I think I'd like to start this discussion there because a lot of the ideas that we apply in this world of matrices, we've already applied before in just the world of real numbers. Now, recall that we talked about identities and inverses as related to one another, kind of like this. With identities, we have an additive identity element, and it is 0. And it is 0 because we can take a real number and apply this operation, addition, with this additive identity element, and we maintain the identity of the item we started with. All right, so that's the idea. For multiplicative identity, same notion. The multiplicative identity is 1 because we can start with a real number like 5 and apply this operation of multiplication on that multiplicative identity element, and we maintain the identity of the item we started with. Okay, then we come to the notion of inverses. An additive inverse is just a fancy way of saying the opposite of a number. Because if we take a number and we add its opposite, we get 0. 0 is the additive identity element. Now notice the relationship back from inverses to identities. Right? We're going to use that kind of backwards relationship with matrices in just a moment, and that's why I'm bringing it up here. Okay, the multiplicative inverse notion is just a fancy way now of saying reciprocal, because if we take a number and multiply by its multiplicative inverse, which is a reciprocal, then we get the multiplicative identity element. Okay, so that's this relationship. Now, we're going to go through a kind of an equivalent operation with matrices to all of these. And what we're driving at is the item that's right down here, a multiplicative inverse idea, and generating what that multiplicative inverse is in the world of matrices. But to develop this idea and have some consistency with it, we're going to go through all of these. Most of them are pretty easy. Consider matrix A plus an identity matrix giving us the matrix A. You see, so the idea of an additive identity element. Right, maintaining the identity of the matrix we started with. Well, the additive identity matrix would be a matrix consisting of just zeros, because when we add these two, we add corresponding entries and we get the matrix we started with. No big deal. In a similar way, the additive inverse idea is that we take a matrix and just the opposite of all of these rascals. So here's the inverse, because when we add those together we get the identity element, the additive identity element, all the zeros in the respective positions in the matrix. Okay, so this is a very expected kind of thing. Now this is somewhat unexpected, perhaps. If we take A, now we're talking in the multiplication world at this point. Let's talk about a multiplicative identity element, right? Which means that we want to take a matrix and multiply times an identity matrix and get the matrix that we started with. See, this is the idea. And it turns out that that multiplicative identity matrix is a matrix composed of ones along the main diagonal and zeros in all of the other parts. Now, notice I'm just choosing as an example here a little 2 by 2 matrix to start with here. So we have a 2 by 2 matrix here. If this were 3 by 3 or 4 by 4 or 5 by 5, the identity matrix would be ones along the main diagonal and zeros in all the other positions. All right, and this works as an identity matrix because of the nature of the multiplication. Now think about that. We've got, let's see, for this entry, we're talking about first row, first column. So we multiply along the first row times the items in the first column here. So 2 times 1, 2, and then 1 times 0, 0. 2 plus 0 is 2. And then down here, we're talking about, let's see, second row, first column. So second row, first column. So we have 5 times 1, 5, plus 3 times 0, 0. That's 5. And then up here, very similar idea for, well, excuse me, it's up here that we're getting an entry for. It's the first row, second column. First row, second column. So it's 2 times 0, 0, plus 1 times 1, 1. And then Second row, second column, second row, second column, 5 times 0, 0, 3 times 1, 3. So the identity matrix. Now, here's what we're trying to do. If we've identified the identity matrix for multiplication, then the inverse is related to that in this way. That is, we take our matrix and we multiply times this inverse, this multiplicative inverse. And notice the notation here is A inverse, you see. But when we multiply those, we need to get the multiplicative identity matrix, which is this matrix that we identified up here. All right, so we're looking for the entries that are in this inverse matrix. All right, multiplicative inverse matrix, I should say. Now, I can find those elements by writing, something like A, B, C, D in here and understand the nature of multiplying here and getting as a result this matrix. And I can make little systems of equations like this. I'm going to go through the process here. You may or may not have to do this on your own. You may have one or two of these for homework, but you're not going to be faced with much of this because we have more streamlined ways of accomplishing this task, and I'll show you those in just a minute. But basically, it's this idea. It is that, okay, we know that we accomplish that element by, since it's in the first row, first column, it is 2 times A plus 1 times B equals 1. And for this item, second row, first column, second row, first column, it's 5 times A plus 3 times B is equal to 0. Now, I chose these two items to talk about because they both involve A and B here. They're both in the first column of this matrix. Now, because they involve A and B, and we've just talked about two equations in two unknowns, we have generated a system of equations. So now that first equation, 2A plus 1B equals 1. I've written that up here. 2A plus B is equal to 1. And the other one was 5A plus 3B equals 0. So we have a system of two equations in two unknowns which we can solve. Now, if we solve it using the method of elimination, I could identify, well, I could pick on the coefficients of the b's here, and so I'll multiply in equation 1 by -3. -3 times 2a is -6a, -3 times b is -3b, -3 times 1 is -3. Then adding the two equations, the b's go out, and I have, let's see, collecting here, -a equals -3, so a is equal to 3. If a is 3, I can back substitute to find the value of b. Now, once I've found the values for A and B, I could come back here and put those values into this matrix. You see, and then I can find C and D in a similar way. Let's do that. I've got 3 here and -5. Okay, for C and D, very similar kind of idea. For this item, you see, it's in the, let's see, first row, second column. So first row, second column. So it's 2C plus 1D, 2C plus D equals 0. And then for this item, it is in the second row, second column, second row, second column. So 5C plus 3D equals 1. And that system of equations is up here. Now, in looking at this, though, I want to make sure we see a comparison of these two. And that's kind of important. We see that 2A plus B is here, 2C plus D is here. 5A, 3B, 5C plus 3D. Notice the coefficients are the same in both of these. All right, that's going to be a little bit important in just a few minutes. All right, if we use the same technique for solving this system of equations, we'll multiply here by -3, and then adding the two, we find -C is equal to 1 or C is equal to -1. Back substitution gives us a D of 2, so we can fill in for C and D. C is -1, D is 2. Now you're thinking that's an awful lot of trouble. And if you really think about larger matrices, like, for example, if we had a system of square matrix now, which is 3 by 3, we would end up with 3 groups of 3 equations and 3 unknowns to solve in order to get the entries in the inverse of the matrix. So there would be quite a lot of work to do. And you may be thinking there must be a better way, and there certainly is. All right, here's another way to approach the problem. Now, this method is still a little bit algebraic in nature, but it allows us to use some of the techniques we've learned about in matrix manipulation to solve for that inverse. And here's how it works. It turns out that if you take the A matrix and then you join it with the identity matrix. Now these are just the entries in the A matrix, the entries in the identity matrix. That if you manipulate this in a particular way to where you have the identity elements in this part of the matrix, then it'll turn out that over here you have A inverse. You see? So we can just go through a manipulative process here in order to accomplish this task. Now, the notion of having I here has to do with the idea that those two systems of equations, we had two systems of two equations and two unknowns. They had the same coefficient part, you see, and the coefficient part was this A matrix that we talked about. And the constants, you see, the constants, the items on the right side of those equations were the entries that appear in the identity matrix. So that's where all of that comes from, and that's why this works. And I'm not going to go into it any further than that. That's a brief and not very conclusive explanation for it, but that's where it comes from. At any rate, let's see, we start with 2, 5, 1, 3. And now the identity matrix elements are 1, 0, 0, 1. And now my intention is to work through and cause these entries to be 1, 0, 0, 1. And then the entries over here will be A inverse. Let's see if that's not the case. Now we're not trying to solve this in any way. You know, when we use this, the techniques involving matrices before, we were solving a system of equations and accomplishing a certain kind of form. We're not doing that at all. We're just manipulating to accomplish a certain pattern here, and that pattern is right here. All of our concentration is right here. We don't care what happens over there. All right, we want to make this element become a 1, and we're just going to play these off of one another. Now I'm going to take it a little bit slow here. I'm just going to multiply here by -2. So it's -2 times row 1. And I'm creating a situation where we have a relative difference of 1 and also a sign change here between these two. So -2 times 2 is -4, -2 times 1 is -2, -2 times 1 is -2, -2 times 0 is 0. And then I'll just bring down this next row. See, and I have this. Okay, now what I'll do is add these two and put the results here. So I'm just taking row 2 and adding row 1. And the result is here. -4 with 5 is 1. 3 with -2 is 1. 0 with -2 is -2. 1 with 0 is 1. Okay, now I'll just bring down the 5, 3, 0, 1. Now think about what we need to do in order to accomplish a 0 right here. Well, we'll play these two off of one another. So it's going to end up being, well, I'm going to go low here, but let's see here. I think I can get one more step in. So here's what I'm doing. I'm bringing this down, the top one, and for this row, I'm multiplying -5 times row 1 and adding row 2. So -5 times 1 plus 5 is 0 as expected. -5 times 1 is -5 plus 3 is -2. Then -5 times -2 is 10 with 0 is 10. -5 times 1 is -5 plus 1 is -4. Okay, so I have this. Now, at this point, now notice that I have entries that are all even through here. So I can, if I want to accomplish a 1 in this position, and that's the next thing I want to do, I'll just divide here by -2. I'm going to put the result up there in just a moment, but we're not going to be able to refer back to this, so understand what we're going to have. We're going to divide here by -2 to give us a 1. We divide here by -2 to give -5. We divide here by -2 to give us 2. Okay, that's what we're going to do in the next step. Let's go up there and do that. So I'm going to write then, just going to bring over that top line. You can't see it here probably, but I'm just bringing it over. And then as I bring these over, I'm doing this. I'm taking row 2 and I'm dividing by -2. So I have 0, 1, -5, 2. Now, the last thing I need to do is cause that rascal to be a 0, and to do that, I'll do this. I'll play these two off of one another, and I'll just say, now, I have to be a little careful about this because I'm noticing that whatever I do right here, whatever operation I do right here, I have to do throughout the 2 rows, and I don't want to mess this arrangement up, you see. So I have to be a little bit careful about this. I don't want to say, for example, the negative of this plus that, because if I do that, it's the negative of this plus that, which would cause a -1 to occur here. So I have to be a little cautious right here. All right, so here's what I want to do. I want the negative of row 2 plus row 1. All right, so the negative of 0 plus 1 is 1. The negative of 1 plus 1 is 0 as expected. The negative of -5 is 5, with -2 is 3. The negative of 2 is -2, plus 1 is -1. And I'll bring down this business. Now, this is the identity matrix entries, and this is a inverse. Let's check that out. We have 3, -5, -1, 2. 3, -5, -1, 2. Now, still, you're probably thinking, well, although this might be a little bit easier if we were talking about a 3x3 or a 4x4 square matrix, it really isn't that particularly easy, is it? I mean, we have a lot of manipulation to go through. Well, it turns out that the graphing calculator is the way to go with this, and I'll show you that in just a moment. I do want to mention, though, before we go to the calculator, that not every square matrix has an inverse. Those that do, those square matrices that have inverses are called invertible, and those that do not are called singular. So invertible if they have an inverse, singular if they do not have an inverse. Let's look at the calculator. To enter a matrix into the graphing calculator, press the button marked Matrix. Now we'd like to edit this matrix, so we're going to press the right arrow key twice. Now we're editing matrix A, and here we are at matrix A with that left icon, so all we need to do is either press 1 or simply enter. The request now is for the order of the matrix. Our matrix is 2 by 2, so we'll press 2, enter, 2, enter. Now the request is for the items along the first row of the matrix, and those items are 2 and 1. So we input 2, enter, 1, enter, and along the second row, 5 and 3. So 5, enter, 3, enter. We'd like to go back to the main screen at this point, and so we want to quit this program. So we press second and then the mode button right next to it. The second function key and then the mode button right next to it will allow us to quit and go to the main screen. To access a matrix and bring it up on the main screen, press matrix again, and now the first item is the one that we want. So we press enter, and here is matrix A. If we'd like to display this matrix, that's fine. We can do so by just pressing enter at this point to verify that we've entered the right information about this matrix. Now to calculate its inverse, we can press matrix again and then enter again at this point. We want the inverse of this matrix, so we'll press x to the -1. That we'll press the key marked x to the -1. And that's simply the inverse button. So A inverse, as we press enter, is this matrix. Inverses of square matrices can be used to solve systems of equations. You know, we've looked at a lot of methods for solving systems of equations in this chapter. We keep going from one method to the next, it seems like. And as it turns out, if you looked at each of those methods, we're just becoming more and more able to solve more and more sophisticated or difficult kinds of systems of equations with each additional method. And this process hasn't ended. We're going to continue this notion throughout the end of this chapter. But at any rate, for what we're talking about right now, we can solve a system of equations by using the inverse of a square matrix. And it works like this. Suppose we have this little system of equations. Now we can think about two matrices being associated with this system. One is the matrix consisting of the coefficients, so the coefficient matrix. And the other matrix is the matrix consisting of the constants. We'll call this the constant matrix. All right, now it turns out to find the solution, in the matrix world, it is that the answer matrix, which we'll designate as X for unknown quantities. Now this answer matrix will contain value of X, value of Y, and I'm calling it the X matrix because of the unknown idea. All right, so the answer matrix is found by taking the inverse of the coefficient matrix, the inverse of the matrix of these coefficients, you see, and then multiplying times the constant matrix, this little constant matrix. And the only tough part here is to generate the inverse of the coefficient matrix. Now, the coefficient matrix, you know, is the 2, 1, 3, 4 matrix. So let's go through that process of generating that inverse, and then we'll find the values for X and Y. All right, we start with the notion of the entries for the A matrix, that coefficient matrix, and that was a 2, 1, 3, 4. And then the items in the multiplicative identity matrix are 1, 0, 0, 1. All right, now we go through that manipulative process. There are a number of ways to go, but what I've done is I've just swapped these two to begin with, all right, putting a 1 in the upper left-hand corner. And you know the pattern I'm trying to create is the pattern that I have right here. So I want to create the pattern here over here. So that's what I'm after. So the first item of business is to cause this item to be 1, and then a 0 here, you see, and then a 1 there, and then a 0 here. That's the flow of this kind of procedure. But at any rate, let's see, I'd like to create a 0 here, so I'm multiplying -2 in row 1 and adding row 2. So -2 in row 1 plus row 2 is what I indicate here. Performing the operations, I get a 0 as this entry. Let's look at the different items that are being multiplied and collected for the other entries here. -2 in row 1 means -2 times 4 is -8, plus 3 is -5. -2 times 0 is 0, plus 1 is 1. -2 times -1 is -2, plus 0 is -2. Now, I'd like to cause a 1 to occur here. There are a couple of ways of doing that, but I think the safest thing to do is to is to divide through by -5. So I'll just take row 2 and divide by -5. Now, it creates some fractions here, but it's really not a big deal. Divide this by -5, we get 0. Divide this by -5, we get 1 as expected. So over here, here's where the fractions occur. Divide 1 by -5, and we have -1/5, and it's a little easier, I think, in this form to write it as a decimal. So we're talking about -2/10 here, so -2/10. And divide this by -5, and we get 2/5, which is 4/10, which as a decimal looks like this. Okay, we're almost done here. All we need to do is cause this entry to be a 0, and to do that, well, let's look up here. I've repeated this step right up here. So I've repeated the matrix that we had below, right here. All right, now we are deciding to cause this entry to become a 0, and to do that we play it off of this entry. So it's going to be -4 times 1 plus 4. So it's -4 times row 2 plus row 1. And the operations are trivial for this entry. By the way, we would be copying this and then writing that. All right, now I've written it all down for simplicity's sake, but it's -4 times 0 plus 1 is this 1. And -4 times 1 plus 4 is this 0. And then -4 times -0.2 is 0.8 plus 0 is 0.8, 8/10. And then -4 times 4/10, you see, is, let's see, negative times positive, -4/10 times 4, that's 1.6. So it's 1.6 negative 1.6 plus 1 is negative 0.6. All right, and all the work is done pretty much here because this is the identity matrix entries, and these are the entries for A inverse. So if A inverse has this value, then away we go with solving the little system of equations. And all of the action, all the hard part has been done for us, because when we go back into this idea that the answer matrix is A inverse times B. A inverse would be the entries we started with a moment ago, times the B matrix, remember, was the matrix consisting of those constants on the right side of the equations. It's just 0 and 3. And we just multiply these two. So let's see. This is a 2 by 2 matrix, and this is a 2 by 1 matrix, because 2 rows, 1 column. And now we take these out, and our answer to this multiplication will be a 2 by 1 matrix. 2 rows, 1 column. And in this form, the top value will be the value of x that solves the system of equations, and the bottom value will be y. So it's an x, y kind of pair here that we're going to read off of the matrix. Okay, let's make the calculation. We have, let's see, for this entry, it's in the first row, first column. So we're talking first row, first column. So 0.8 times 0, it's out of here. Negative 0.6 times 3 is negative 1.8. So negative 1.8. And then for the second row, first column, second row, first column, so it's negative 0.2 times 0 out of here. 0.4 times 3 is 1.2. So 1.2. So we know then that x is equal to negative 1.8, y is equal to 1.2 as the solutions to this system of equations. Let's see how the calculator would handle the situation. Pressing the matrix button and cursoring 2 to the right, and then pressing enter, we can overwrite the matrix that we had on board earlier. Now we want to enter a 2 by 2 matrix here, so we'll press enter here and then enter. Now the items at the top of this matrix are 2, 3, so I'll overwrite the 2 or just press enter, and then 3 for this one, enter. And along the bottom row, 1 and 4. So 1 enter, 4 enter. Now I'd like to input information about another matrix. So I'll press the matrix button. I'll go over to edit again, and I'll cursor down 1 for matrix B. Now this matrix is it has 2 rows, 1 column. So it is a 2 enter by 1 matrix. Now the items I want to enter are 0 and 3. So 0, then 3, enter. I'd like to go to a main screen at this point and make the calculation for A inverse times B. So second and then quit. Now let's see, I'd like to bring up matrix A and then take its inverse. So press the matrix button and now enter at this point. So here we have A. Press the inverse key, which is the button marked x to the negative 1. Now I'd like to multiply, so I'll press the times button. I'd like matrix B, so I press matrix again and cursor down to B, press enter. Now this is A times B. Pressing enter, I get the answer matrix. Negative 1.8 for x and y is 1.2, as we expected. Let's use this inverse of a square matrix idea to solve this system of 3 equations and 3 unknowns. Now if we were to do this sort of by hand, algebraically, we would need to write this coefficient matrix. Now I've written it here and designated it as A. And we would have to find A inverse. Now that process would be rather lengthy. We would have to set up the notion of the entries here and also the entries for the multiplicative identity matrix you see over here, and then create a situation where those entries appeared over here, and then the entries that appeared over there would be A inverse, you know, and that kind of stuff. So it would be a little bit involved in that way. Well, let's see. Now, using the calculator, we're going to identify matrix A as this matrix. Matrix B is the matrix consisting of the constants. And the answer matrix will be A inverse times B. Turns out that the hardest part of this using the calculator is just entering the items in matrix A. Let's have a look. To enter our 2 matrices, we press the matrix button, cursor over to the right, and we'll do some editing here. Now, we can overwrite the previous matrices. I would like to show you how to eliminate the matrices that are on board if you care to do so sometime in the future. Now, to do that, you would press the second function button and then the button marked with the plus sign. Second plus is the memory button, and cursor down to delete, press enter. Now, we'd like to delete matrix information, so I'll press enter at this point. And it's really a requester here for which of these or both we wish to delete. If I want to delete A, I'll press enter here, and then enter again will delete both of them. Now let's go back to the main menu, second quit, and then matrix. Now notice that there's no information here for matrices A and B. All right, let's go through the editing process again, cursoring over to the right, pressing enter. The matrix that we're talking about is a 3 by 3, so the order is 3, enter, 3, enter. And now along the top row we have 3, 2, 2, so 3, enter, 2, enter, 2, enter. Along the second row, 2, 2, 2. Along the third row, negative 4, enter, 4, and then 3. Now I'd like to edit the next matrix, so let's press matrix and then over to edit and then cursor down to B, enter. I'm entering a 3 by 1 matrix this time, so we have 3 rows, enter, and 1 column. So we're entering negative 1, enter, then 2, 0. Now the matrix B is on board. I'd like to go back to the main menu, second quit, matrix. I want matrix A, so I'll press enter at this point. I want the inverse of A, so I press X to the negative 1. Now I'd like to multiply times matrix B, so I'll bring up matrix B by pressing the matrix button, cursor down to B, press enter. Here it is, press enter again, and here is our answer matrix. So X is negative 3, Y negative 24, and Z 28 for the solution to this system.